Students, are you able to hear me?
Yes, sir.
So we'll get started.
Yes, sir.
So we'll get started. We are discussing 16.2 yesterday. So we saw the first problem. Now we'll see the second one. Second one states a die is thrown. Describe the following events. A, number less than 7. Put it in a set form. So number less than 7 means 1, 2,
1, 2, 3, 4, 5, 6.
Yes. B, number
Null
greater
set.
than 7. Null set. C,
3 and 6.
3 and 6.
3 and 6.
D,
1, 2, and 3.
1, 2, 3.
yes. E is an even number
6.
greater than 4. It is only 6.
6.
F is number not less than 3. Means
3,
4,
4,
5, and 6.
it
You
is
can
4,
include
5.
3, no, sir. Since it's not less than 3, sir. It's equal to 3. So 3 can be included, right?
Not less than 3. So excluding less than 3 means excluding. Yes, it can be 3 also. Okay, 3, 4, 5, 6. Now what are they asking? Find A union B. A union B is nothing but A only. That is 1, 2, 3, 4, 5, 6. And find A intersection B. A intersection B is a null set.
Null set.
So they are asking what is E union F also. E union F will be how much?
3, 4, 5, 6. F, sir.
Yeah. So D intersection E will be?
Null set.
Null set.
Okay, null set. Anything else they're asking? A minus C. So what is A minus C? What is the difference between A and C? What is
A
there in
only.
A? What is the difference? No, what is there in A which is not there in D? Sorry. Oh, A minus C, no. What is there in A which is not there in C?
1, 2, 4, 5.
Yes, because A minus C is the same as A intersection C dash. Right? So they both are same. Similarly, what are they asking? D minus E. What is D minus E? What is there in D which is missing in E?
1, 2, and 3,
1,
sir.
2, and 3.
1, 2, 3.
Just 1, 2, 3. Similarly, what is only F dash? What is F complement? 1, 2. What else are they asking? E intersection F dash. E intersection F dash is E has 6, F dash has 1, 2. It's a null set.
Null set.
Okay. Now let's try to understand one thing. A and B put together, can I call them as exhaustive sets?
Yes, sir.
And they are mutually
Exclusive set.
they are mutually exclusive as well. Similarly, D and E are mutually exclusive. E and F dash are mutually exclusive. Okay. Shall I move on to the next one? Now listen. An experiment involves rolling a pair of dice and recording the numbers that come up. Describe the following events. A. The sum is greater than 8. So 2 comma 6 and 6 comma 2 will generate 8. So I should start with minimum of 3. 3 comma 6, 6 comma 3. If I start with 4, 4 comma 5, 5 comma 4. If I start with 5, 5 comma 6, 6 comma 5. If I start with 6, only 6 comma 6. Okay, sum is greater than 8. Well, then what about B? 2 occurs on, how many dice are rolled? So 2 occurs on either die. So what is the meaning?
1 comma 2, 2 comma 1,
Okay,
2 comma 2,
okay.
3 comma 2, 2 comma 3,
Then
4
4
comma 2,
comma
2
2,
comma 4.
2 comma 4,
that's right.
5
5
comma
comma
2,
2,
2 comma 5, 6 comma 2, 2 comma 6.
yes. 2 occurs on either die. C. The sum is at least 7. The sum is at least 7 and a multiple of 3. So at least 7. The sum should come out as 7 and a multiple of 3. Both, however, 7 itself is not a multiple of 3. So minimum 7 means. So both should happen. So sum is at least 7 means.
So then it will be A only, no, sir. Set A.
No. Here the sum is greater than 8. Here what are they saying? The sum is at least 7 and also a multiple of 3. So do I need? Okay, see. For this
3
what we will
comma
do is, first we will dissect and write. In the sense we will write it as 2 separate events. Suppose I say x is sum is at least 7. Sum is at least 7 means 1
1
comma
comma 6.
6 comma 1. 2 comma 5, 5 comma
5.
2. 3 comma
Even
4.
2 comma 6.
No, I'll come in the order. I'll first finish 7. 3 comma 4, 4 comma 3. Then 5 comma 2 is over. 6 comma 1 is over. So all these numbers give 7. At least 7 means 7, 8, 9, 10, 11 or 12. Right? So it's a very big set actually. I'm just writing for the sake of expansion. You will understand it. Then for 8, what should I do?
2 comma 6, 6 comma 2,
Yes.
3
3
comma
comma
5 and
5.
5 comma 3 and 4 comma 4.
So if you keep writing it like this, according to C, the sum should be at least 7 and it should also be a multiple of 3. Means from all these ordered pairs, I need to choose whose sum is minimum 7 or greater than it and also a multiple of 3. So what is the multiple of 3 that is possible greater than 7 in this case? It can either be a
9
9
and 12, sir.
or 9.
9,
So
12.
what should the set C be? 3 comma 6?
3 comma 6, 6 comma 3, 4 comma 5,
Yes.
5 comma 4,
Yes.
and 6 comma 6, sir.
6 comma 6.
That's it. Huh? That's it. Now they're asking which pairs of these events are mutually exclusive. Mutually exclusive means there is no intersection at all. So which are mutually exclusive?
A and B, sir.
A and B are, because in A there is no 2, in B everywhere there is 2. Right? So A intersection B is a null set. Similarly, what about A and C? A and C will not work. Right? A and C
Yes,
is
sir.
3 comma 6. A and C will not work. Then what about B and C?
Yes, sir.
No, sir.
I think they are, no?
Yes, sir.
Yes,
They
sir.
are
They're not
mutually
exclusive.
exclusive.
Because here you have 2, in C you don't have 2 at all. So B intersection C is also a null set. A intersection B is also a null set. So A and B are mutually exclusive and B and C are also mutually exclusive. Right?
Yes, sir.
Yes. Shall I move on? See,
Yes, sir.
3 coins are tossed once. Let A denote the event that shows 3 heads. So A is equal to what? Head, head, and head. And B denote the event of 2 heads. So 2 heads means it can be head, head, tail, head, tail, head, tail, head, head. Oh, 2 heads and 1 tail show. Okay, that's right. C denote the event of 3 tails. So 3 tails. D denote the event of heads on the first coin. So head, head,
Head,
head.
head, head.
Head, tail, head.
Tail. Head, tail, head. Head,
Then
tail, tail.
that's it, no?
Yes, sir.
Because you will have 8 outputs. Out of the 8 outputs, 4 outputs only will have heads in the first. Now, which of the events are mutually exclusive? A intersection B
A
is a
and
null
C.
set. B intersection C is a null set. A intersection C is a null set.
C intersection D also.
C intersection D is a null set. B intersection D exists, no?
Yes, sir.
HHD and HTH. They both match. So all these are mutually exclusive. Which events are exclusive? So AB are exclusive, BC are exclusive, AC. A, B, C taken together are also mutually exclusive. Right? If I ask you what is the intersection of A, B, and C together, that is also null set. Right? Second,
Yes.
which events are simple?
A and
A
C.
are simple, and which are all compound? B and D
B
are.
and
B and D are compound.
Okay. So make a note of this. Then shall I move on to the next one?
Yes, sir.
So 3 coins are tossed. Describe 2 events which are mutually exclusive. So it's up to us. See, it's up to us. We can define an event like this: head, 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 and even B as tail, tail, tail. So these are the 2 events which are mutually exclusive. Right? Similarly, 3 events which are mutually exclusive and exhaustive. So they're asking us to think, means we need to frame the scenarios. Okay. Okay. So I will define the events like this. Event A is getting all heads. Event B is getting at least 1 head. No. Hitting at most 2 hits. At most 2 means tail, tail, tail is also possible, no? We want 3 events which are mutually exclusive and exhaustive. At most 2 hits will not work. At least 2 hits. So getting all hits, getting at most 2 hits. When I say at most 2 hits, all the tails will also come. Can we think of any event? Guys, can you think?
Mutually exclusive, it's 3 heads and 3 tails.
See, exclusive 3 heads, 3 tails I can take, but they're asking 3 events which are mutually exclusive and exhaustive. No? I can take these 3, no? Okay, see. I can take one of the events as 2 heads and 1 tail show. Right? And the event A as all 3 heads. 1, 2, 3, 4. So they should be mutually exclusive and exhaustive, right?
So here the order is not the same. Is it still counted?
Which order is not same?
Like head, head, tail, and head, tail, head.
No, because I
same.
took
Is
at
it
most
same?
2 heads. I can define it like this. I'll take it like this. Getting 1 or 2 hits. C, getting no hits. It's up to me. Right? So will this work? See? So what is event A? Head, head, head. Event B is getting 1 or 2 hits.
Yes,
That is
sir.
head,
It's
head,
come.
tail. It will work. No. Head, tail, head. Head, tail,
Okay.
tail. Tail, head, head. Tail, head, tail. And tail, tail, head. This is getting 1 or 2 hits. And C is about getting no hits. T, T, T. If you see A intersection, B intersection, C is null set because nothing is common in them. Similarly, A union, B union, C will give us 1, 2, 3, 4, 5, 6, 7, 8. It will give us the sample space. So they are mutually exclusive and exhaustive. Right? Shall I move on?
Yes, sir.
Okay. Oh, they're still asking 2 events which are not mutually exclusive. This we can easily define. You can define one event as getting all hits.
More
Getting
than 1 head, sir.
getting at most 3 hits. So getting 3 hits is head, head, head. When I say getting at most 3 hits, then it's a whole sample space. So A and B will have head, head, head as common. So they are not mutually exclusive. So you need to define 2 events which are mutually exclusive but not exhaustive. Then what can we do? For fourth one, A can be head, head, head. B can be tail, tail, tail. They are mutually exclusive, but they are not exhaustive.
My city dry.
So 3 events which are mutually exclusive but not exhaustive. Then we can define it like this. Head, head, head. Tail, tail, tail. Head, tail, tail. Are they not mutually exclusive? I took simple events. 3 heads, 3 tails, and 2 heads. All these 3 are mutually exclusive, but it is not exhaustive. Okay. Next is 2 dice are thrown. The events A, B, and C are as follows. Event A is getting an even number on the first die. Event B is getting an odd number on the first die. Event C is getting the sum of the numbers on the dice less than or equal to 5. So getting an even number on the first die. 2, 1,
2, 4,
2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Similarly, 4, 1, 4, 2, so on till 4, 6. 6, 1, 6, 2, so on till 6, 6. Okay. Getting an even number on the first time. Next, B is what? Getting an
1,
odd number on the
1,
first. Yes, 1, 1.
1, 2, 1, 3 till 1, 6, sir.
Similarly, 3, 1,
3, 2 and till 3, 6.
5, 1,
5,
5, 2.
2 and 5, 6.
Next, C is getting the sum of number on the dice to be less than or equal to 5.
2, 1, 2, 2, 2.
What about 1, 1?
Yes, sir.
1, 1, 1, 2, 1, 3, 1, 4.
1, 4.
2, 1, 2,
2,
2,
2.
2,
2
3.
3 3 1 3 2.
And
4,
4, 1, sir.
4. That's it, right? Describe the events A dash. So I'm not wrong, A dash is nothing but B.
Yes, sir.
A dash is B. Similarly, not B. B dash is nothing but A. They're asking A or B. What is A or B?
Intersection A.
It's the sample space.
Yes, yes, sir.
Yeah. So A and B are exhaustive events. Right?
Yes, sir.
Shall I move on? Oh, there are some more questions. Huh? A and B. A intersection B is obviously a null set because A is starting with all even numbers, B is starting with all odd numbers. So it's a null set. Next is A but not C. A intersection C dash is how much? So C is about getting a number less than or equal to 5. What is C dash B? Getting a number strictly greater than 5. So in A, find out where all you have the sum of the numbers to be greater than 5. That is 6, 7, 8, 9 till 12. So 6 starts at 2, 4,
2, 5, 2,
2, 4, 2, 5.
2, 5, 2, 6.
Okay.
And 3,
4,
3.
3 is, no, 3 will not
4,
be there. No,
2, sir.
4, 2, 4, 3, 4, 4.
Till 4, 6 and then 6 fully, sir.
4, 5 and 4, 6. Next. 5, 2.
But sir, 5 is not there, no,
The
sir.
5
5
won't
is
come,
not
sir.
there. Yo, 6 will come then.
So full of 6 will come, sir.
6 full, sir.
6, 1,
6 2 till
4.
6 6.
Yes. That is A intersection C dash. What about B or C? B union C. B or C means so B or C means just write down all the numbers. So 1 1. Okay. 1 1, 1 2, so on till 1 6. Because B starts with odd number. Then 2 1, 2 2, 2 3 because this is coming from C. And 3 1, 3 2, so on till 3 6. Then 4 1. Then 5 1, 5 2, so on till 5 6. Okay, wow. Is it fine? 5 6. So this is all about B union C. Oh, such a big question. We have B and C also. Huh? So what is B intersection C? 1 1, 1 2, 1 3, 1 4.
Set of C, sir.
3 2.
No, it will not be set of C because C
Yes,
has
sir.
2.
Except 4 comma 1, sir.
No. 2 will also miss.
Yes, sir.
It will be only this value. Yeah. So B intersection C is this thing. What is A intersection B dash intersection C dash? See, B dash is nothing but A. So what is A intersection A dash? Sorry, B dash is nothing but A. So what is A intersection A? It is A only. So this is the same as A intersection C dash. Did you guys understand what I did?
Yes, sir.
So for that, I need to write C dash first. See, can you guys write C dash and tell me first? 1 5, 1 6,
2
2
4,
2
4,
comma 4, 2 comma 5, 2 comma
yes,
3
2
comma
6
3, 3 comma 4, 3 comma 5, 3 comma.
till 3 6, then 4 2 to 4 6. So 1 5, correct? 1 5, 1 6, 2
So we
4.
shouldn't include 5 and 6, sir. 5 comma 1, 5 comma 2.
Where?
For C
Yeah,
dash.
we need one. I didn't write it. Yeah, we need to.
Okay,
I'm trying
sir.
to write it because of the space constraints. So 3 comma 3, 3 4. So C dash is about numbers greater than 5, no? 3 4, 3 5, 3 6. Then 4 2, 4 3, so on till 4 6.
Comma 6, sir.
5 1, so on till 5
5 comma
6.
6. And 6
6
comma
1
1
till
till 6 comma 6.
yes. Now, what is A intersection C dash? What is in A? In A, the first digits, the first number should be even. So look at only even numbers. So A intersection C dash will be these numbers, and these numbers. So it will be 2 4 2 5 2 6, 4 2 4 3 till 4 6, 6 1 6 2 till 6 6. 2, 4, 2, 5, correct? 2, 5, 2, 6. Okay. 3, 3, 3. Sorry, no 3, no. Because it's intersection. 4, 2, 4, 3, so on till 4, 6. 6, 1, so on till 6, 6. Right? So this is A intersection C dash. Got it, guys?
Yes, sir.
Next. Refer to the question 6 above. A and B are mutually exclusive. Huh? Yes. A and B are exclusive. True. A and B are mutually exclusive and exhaustive.
Yes, sir.
A union B is sample space. They are exclusive and exhaustive. True. A is equal to B dash.
Yes, sir.
That is also true. So all are true. Are there any more questions? Yes. A and C are mutually exclusive. A and C are not mutually exclusive because 2, 1 is common. So it is false. A and B dash are mutually exclusive. No, they are not because A,
Because B dash is equal to A, sir.
it's A. So A intersection A is nothing but A only. It's not a null set. So this is also false. A dash, B dash, and C are mutually exclusive. Again, I have to sit and do A dash, B dash, and C.
No,
If we
sir.
do
A
anywhere,
dash is B and B dash is A, sir. A, B
okay.
and
So
C
we will.
we are.
So A dash intersection B dash intersection C. So A dash is B. Intersection B dash is going to be a null set. Intersection C will be C. They are not mutually exclusive. Did you understand what I did?
Yes, sir.
So it is null set. Oh, wait. It's a null set. An intersection of a null set with a set is also a null set. So it is exclusive. What about exhaustive? A dash, sorry, B union B dash union C. What is B union B dash? It's the sample space. Yes, no, they are mutually exclusive and exhaustive. True. Is there anyone having a doubt on this? So since A dash is B, I wrote it as B. The intersection of a set and its complement will be a null set. So intersection of a null set with a given set is a null set. So they are mutually exclusive. Similarly, B union B dash is the sample space. So sample space and the union of any other set will be the sample space. So that is why it is exhaustive as well. Oh, that's it. Okay. So I hope you're clear with all these things.
Yes, sir.
Now see. So till now, what we did, we tried to understand how to write the sample space, and we discussed about the different kinds of events that are existing with the help of set theory. So till now, we didn't touch the definition of probability at all. Now we are going to see what is the axiomatic definition of probability. Okay. So what I'm going to do is I'm going to tell you in terms of the number of elements in an event and the number of elements in the sample space. Okay. So I'll directly go with the Venn diagram. Okay. If number of elements in A, if n of A represents the number of elements of event A, and n of S represents number of of sample space, okay, then probability of event A, you read it as probability of event A is given as number of elements in A divided by the number of elements in sample space. So this is going to be the definition of probability going forward. So till now you would have learned as number of favorable outcomes divided by the total number of outcomes. But here it is with a different perspective. What is it? We are going to speak in terms of the number of elements in set A to the number of elements in the sample space. Okay. So to understand this, what we can do is, in the previous exercise, let us take few problems and try to write the probability of those events using this definition. Okay. Now understand this. So I'll do the basic ones. Suppose if I take a die to be rolled, then what are the number of elements in the sample space? I need not sit and write everything. So what are you? How many elements does a universal set contain?
6, sir.
It has 36. Oh, die is rolled. Sorry, it is 6. Now, the event E is defined as die shows a 4. So how many? Is it a simple event or a compound one?
Simple.
Simple. So what is the probability of E to occur?
N of E by N of S. 1 by 6.
1 minute. So it is 1 by 6. That is N of E divided by N of S. That is 1 by 6. Are you guys able to understand? Last year you would have learned it as number of favorable outcomes. How many outcomes is possible for the die to show 4? This 1 divided by the total number of outcomes. Are you guys able to understand? Similarly, for the die to show an even number, what is the probability of F? That is the number of elements in F divided by the number of elements in the sample space. So what are the number of elements in F? There are 3 elements divided by 6. It is 1 by 2, which is 50% probability. Means when you roll a die, you have 50% even numbers and 50% odd numbers, right? So that's the meaning. So are you able to understand the axiomatic definition of probability? So how you are defining in terms of the number of elements,
Yes, sir.
right? So see, all other basic things you know, right? See, all these things whichever are given here, I will slowly prove it and show. I'll show you with the Venn diagram. I don't want to read out what is the theory given there. Next, what is the range of probability? The range of probability is between 0 to 1. Okay. So let us do this example 9. Let a sample space S be omega 1, omega 2, so on till omega 6. Find the following, which of the following assignments of probabilities to each outcome are valid. That is the meaning. So what they are trying to say is the outcomes are omega 1, omega 2, omega 3, omega 4, omega 5 and omega 6. The probability of omega 1 alone to occur is 1 by 6. In the case 1, in this case, probability of omega 1 to occur is 1 by 6. Probability of omega 2 to occur is 1 by 6. Probability of omega 3 to occur is 1 by 6. Similarly, till 6th one, it is 1 by 6. They are asking whether this is a valid set of probability or not. Whether this kind of a probability event is possible or not. So how to verify this is, first thing, if you check the probability of each case, how much is it? It is less than 1. It is 1 by 6, right? Next, if I calculate the probability of omega 1 union omega 2 union so on till omega 6, my answer should come out as 1 because omega 1, omega 2 so on till omega 6 is going to be the probability of sample space. Guys, am I clear with this? So omega 1 union omega 2 union till omega 6 is going to be sample space. So probability of sample space is 1. We know this because according to the axiomatic definition that I gave you, what is the probability of sample space? Number of elements in sample space by the number of elements in sample space. That will be 1. The denominator is by default n of s. Numerator will keep changing according to events. So what I'm trying to say is, when you add all these probabilities, if it comes out as 1, then that kind of a probability set is valid. So tell me, is option A valid or invalid? Guys, if you want, I will read this out. Listen, I'll tell you the reason of why it is done. So probability of each event is between 0 to 1. Similarly, the sum of probabilities of individual events should come out as 1. Okay, so it should come out as 1. These are the two important factors. Now tell me, is this condition satisfied here? Is each probability less than 1? 1 by 6, each is less than 1. Then what is the sum of all the probabilities?
6 by 6, which is equal to 1, sir.
So 1 by 6. So it's a valid one. Now what about the second one? So second is a separate case. They're saying, is this kind of a combination is possible or not? They're not saying what kind of event and all. They're just asking you to verify the axiomatic theorem of probability. You need not worry about what scenario it is. So they're saying, we don't know what is omega 1, omega 2 also, some random event. If you take B, then probability of omega 1 is given as 1. The probability of other events is 0. Is this kind of a scenario possible or not? The answer to this is yes. Why? Because the probability of a particular event can either be 0 or at the max 1. Secondly, what condition is to be satisfied? The sum of the probabilities of all individual events should come out as 1. In this case, is it coming out as 1?
Yes, sir.
So it is possible. What about C? 1 by 8, 2 by 3, 1 by 3, 1 by 3, minus 1 by 4, minus 1 by 3. What do those tell us? It is. So they're trying to say probability of omega 5 is minus 1 by 4. Probability of omega 6 is minus 1 by 3. Is this kind of a scenario possible? Obviously,
No,
no, because
No, sir.
probability cannot be negative. What about D? 1 by 12, 1 by 12, 1 by 6, 1 by 6, 1 by 6. But here you have 3 by 2. So why is 3 by 2 not possible?
It is greater than 1, sir.
It is greater than 1. It is 1.5. It is also not a valid scenario. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. If you look at them, every value, every probability is less than 1. But
The sum is greater than 1, sir.
the sum is greater than 1. So this is also not a valid scenario. Am I clear in this problem? Is there anyone having a doubt?
no, sir.
No doubts.
Now let us see what is the probability of an event. I already told you, probability of an event is defined as the number of elements in that event divided by the number of elements in the sample space. So to make us understand, they are given as an example. Okay, let's see. Let S be a sample space associated with the experiment of examining 3 consecutive pens produced by a machine and classified as good and bad. So good pens are non-defective, bad ones are defective. We make, so how many defective pens are possible as a result? Okay, how many machines are there? Only one machine. So a machine is producing pens. Okay. So the pen which is coming out of the machine might be a defective one, might be a good one. We don't know. But what are all the possible values of defective that are possible that can come out? You can either get a 0 defective pen, means the machine can generate 100% good pens, or it can generate 1, or it can generate 2, or it can generate 3, because how many pens are checked? Only 3 consecutive pens are checked. Okay. So what will be the sample space for this, guys? So it is again like bad or good means it is similar to a coin. You can get 4 bad, 4 good, 2 bad, 2 good, 2 bad, 2 good, bad good, bad good, bad good, bad good. Right? So where B stands for defective, that is bad one, and G stands for a non-defective one. You can use D also. Now comes the question. What is the probability of getting all pens to be bad? So if I take BBB, how many, so that event contains how many numbers, how many elements in it? If I take BBB alone, from the sample space, this constitutes of how many number of outcomes?
One, sir.
This is one outcome. This is one of the outcomes of the 8 outcomes that we have in our hand. So each outcome will have a probability of 1 by 8. Are you guys able to understand? Now, they are trying to define an event A. So the event A is about there is exactly one defective pen, and event B is about there is at least 2 defective pens. So can you tell me what is the set for event A? There is exactly one defective pen.
Good, good, bad. Bad, good, good.
Okay. Good, bad, good. Right? Similarly, B is about there are at least 2 defective pens. Bad, bad, good. Bad, good,
B,
bad.
G.
GBB.
Good or bad.
There are at least, so all are bad. So there are 4 scenarios that are possible. Right? Is there anything I'm missing? 3, 2, 2, 2. Yeah, 4 outcomes. Right? Now, what are they asking? If I have to calculate the probability of A, what will you say? You can actually go with the definition that I gave you. They're trying to prove something. So what is the probability of A, guys? It is the number of elements in A divided by the number of elements in sample space. That will be 3 by 8.
3 by 8.
So how did you actually get this 3 by 8 is because it is a probability of this event. That is, what is the probability of having a good, good, good one? 1 by 8. What is
1
the
by 8.
probability of having bad, good, good, bad, good,
1
good
by
as well?
8.
That is also 1 by 8. And probability of having good, bad, good is also 1 by 8. Which one? This one. So all these 3 put together is going to give you how much? 3 by 8. That 3 by 8 you can directly get it from the definition which I gave you. That is the number of elements in the event A, set A divided by the number of elements in the sample space. Similarly, what is the probability of B, guys? 4 out of
1 by 2.
1 by 2. How did you get that 1 by 2? It is a sum of bad, 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 good, bad, good, bad, good, bad,
Good,
bad.
bad, and
The first 4,
bad, bad, bad.
sum of the first 4 probability. That is 4 by 8, which is again 1 by 2. I hope you're able to understand. So this is what we are going to do in this exercise. Okay. Similarly, let's do one more problem. Let us consider another experiment of tossing a coin twice. So sample space is head, 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 tail, tail, head, tail, tail. So probability of head, head is 1 by 4. That is, probability of individual event or probability of each sample point is the same. 1 by 4. Probability of head, tail is 1 by 4. Probability of tail head is 1 by 4. Tail, tail is also 1 by 4. Okay. See, actually speaking, they are supposed to be the same, but in this question, what they have done is they themselves have given this kind of probability. So understand what they have told. So what is the probability of head comma head they have given? Sorry, head head they have given 1 by 4. Probability of head tail they have told 1 by 7. Probability of tail head is 2 by 7. Probability of tail tail they have given it as 9 by 27. Clearly, this assignment satisfies the conditions of axiomatic approach because each probability of each sample point is less than 1 and the sum of all the probabilities should come out as 1. Is it coming out? Let's check. The LCM is 28. 7 plus 4 plus 4, 4, 8 plus 9. 8 plus 9, 17, 21, 21 plus 7, 28 by 28. Yes, the sum of all the probabilities is 1. Right? So this kind of a scenario is possible. That's what they told. Clearly, this assignment satisfies the conditions of axiomatic approach. Now let us find the probability of event E. So what is the event E they are trying to define? Event E is what? Both the tosses yield the same result. So both the tosses yield the same result means both tosses should give us either head head or both should give us tail tail. So that is probability of getting a head and a head plus probability of getting a tail and a tail. What is the answer for this, guys? 1 by 4 plus
9 by 28.
9 by 28. That will be 7 plus 9, that is 17 divided by 28. 17 by, sorry, 16 by 28. 16 by 28. So if you try to reduce it, it will be 8 by 14 or
4 by 7.
4 by 7. Right. So event F, they have defined it like this, exactly 2 heads. So what is F, guys? Exactly 2 heads. So head head. So what will be the probability of F? Probability of just getting head and a head, that is 1 by 4. Right?
Yes, sir.
Now, see, there is something called as probability of equally likely outcomes. So probabilities of equally likely outcomes means each outcome will have the same amount of probability. The best example for this is this one. If you observe, probability of any sample point you take, sample point, okay, probability of any sample point you take, it is 1 by 8. So this is an example of equally likely. Whereas if you take this scenario, if you take this scenario, what can you say?
The
Is it an
probabilities
equal?
of everything is not equal.
It is not equal. So let a sample space of an event of an experiment be omega 1, omega 2, so on till omega n. Let all the outcomes are equally likely to occur. That is, the chance of occurrence of a simple event must be the same. So if I take any random sample point and write its probability as P, then we know that the sum of all the probabilities of individual events should be equal to 1. Right? So probability of each outcome will be equal to 1 divided by n. That's what they're trying to say. Anyways, this is not a point where you have to memorize or something. It's an understood point. So you need not worry much about this point. I'll get into the more detailed concept. If I complete this, you will understand why this is happening, why we are adding all those things. Okay. Shall I proceed with this?
Yes, sir.
Okay. Now listen. So, if suppose probability of an event A or B. So what do you mean by A or B? It is A union B. They're asking what is the probability of A union B. That is, if you know the probability of A, if you know the probability of B, how will you be able to calculate the probability of A union B is the question. I suggest everyone to write it down. Okay. if I take the sample space S, A and B are there. Okay. Now what is this place? It is A intersection B. Now tell me one thing, guys. If I ask you what are the number of elements in A union B, what will you say? They are the number of elements in A plus the number of elements in B minus
Minus A intersection B.
number of elements in A intersection B. So now I'm going to divide with n of S on both sides. Okay. So number of elements of A union B divided by n of S is equal to n of A divided by n of S plus n of B divided by n of S minus n of A intersection B divided by n of S. Now tell me, guys, n of S is common in everything. I told you for every definition of probability, you will have the number of elements in the sample space in the denominator. The numerator is going to define the probability of that particular event. Here, what is the event? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Is this clear?
Yes, sir.
Okay.
Yes, sir.
So what they would have done in this example is they would have considered an example. They would have proved that probability of A union B is not equal to probability of A plus probability of B, but there is something else. What is that something else? You should subtract it from probability of A intersection B. This one, what I explained, is technically called as addition theorem of probability. Please make a note of it. So most of the problems that we are going to solve will be based on this theorem only. So that's what this whole story is. Okay. Am I clear, guys? So this is the formula that I gave you. Okay. So please write it down again. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If A intersection B is equal to null set, then what are those events? They are
Probability of A plus probability of B.
They're mutually exclusive, right? Then probability of mutually exclusive events will be 0. In that scenario, what will happen is probability of A union B will be equal to probability of A plus probability of B. So that's what the given says. For mutually exclusive events A and B, probability of A union B will be equal to probability of A plus probability of B. And this is the reason why we are able to add the probabilities here, because each sample point is a mutually exclusive one with another sample point. Means if you take a simple event, each simple event is different. So if you take all the simple events, no, all the simple events are definitely mutually exclusive, because BBB is a simple event, BBG is a simple event. Between two simple events, obviously there will be no intersection, and that was the reason why we added the probabilities there. Are you guys able to understand? I'm just doing a reverse analysis. Are you able to understand why we are actually adding them?
Yes, sir.
Okay. So this is an important formula, guys. Remember this. In the next class, I will complete this chapter. Actually, theory part is over. Now we have to do only problems. So next class, we will complete it. Okay. How many problems are there? 21. We can, maximum 2 more classes, we can complete it. Okay. Is there any doubt from today's class?
No, sir.
No, sir.
Good. So just wait for a minute.